In this video, we're going to look at what are called qualitative graphs. A qualitative graph describes a function visually, not with exact numbers. It can have sections with horizontal segments, meaning no change or movement, and it can also have curved lines to show that the slope or the rate of change is not constant. Okay, so that's kind of our definition, so we're going to look at a couple examples here. The first example, we have a graph. And it's always important to look at our graphs, what our axes are labeled. So here we have the y-axis as ball's distance from the ground, and our x-axis is time. The majority of the time, our x-axis will be labeled with time. Okay, so if we look here, what they want us to do is describe what's going on in this situation. Okay, so if we have this label, ball's distance from the ground, as our y-axis increases, our distance is increasing from the ground. So we would say that the ground is right here, okay, or the x-axis represents the ground. So if we think about how this graph looks, it kind of looks like some loops, right? So if we're talking about a ball, this could maybe mean that since our height starts up on the y-axis, the ball is not starting on the ground. So we are tossing a ball, and we throw the ball, and as the ball is in the air, we know that gravity is working upon it, so it brings it to the ground, hits the ground, and then it bounces up. But it's not as high as the first height on our graph, the first segment, because it lost some of its momentum as it hit the ground. So you can kind of imagine a ball tossing it up, hits the ground, bounces up a little bit, and it's losing some of its velocity, some of its speed, and as a result, some of its height. So how can we describe this? We could say that we toss a ball in the air, and the height that the ball reaches from the ground decreases with each bounce. And we know that's true because of gravity. Okay? So that's one example we could see. They give us a graph and we have to describe what's going on. The second example we're going to look at is they give us the situation and they want us to graph it. Okay, and this one will be a little bit different. Okay, here's our scenario. It says Coach Roper drives to school one morning. After he leaves his house, he drives at a constant speed until he reaches school. After school, he drives home at a constant speed, but decides to stop at Sonic on the way home. After that, he continues home at the same speed as before. So we look at our labels here, distance from school and time. So the key word here is school. So as our y-axis increases, we are farther from school, right? So school would be down here. So it says we drive to school one morning, all right? So after he leaves his house, he drives at a constant speed. So I like to underline the parts of our graph here, the different sections. So we're starting at our house, right? So we're not going to start down here, because down here, remember, is school, right? So we're going to start somewhere up here, and that's going to represent us starting at the house. And it says after he leaves his house, he drives at a constant speed until he reaches school. Okay, so we're talking about distance here. So we have our constant speed until we have reached school. Okay, so we started at home and we're on the way to school. Okay. After school, he drives home at a constant speed, all right? After school, all right? So time increased, right, while we were at school. So we have a horizontal segment down here. Our distance did not change because we were at school the entire time, right? My distance from the school didn't change. So we left the house, got to school, taught math class all day. Now it says we drive home at a constant speed, but decided to stop at Sonic on the way. So stop at Sonic on the way home. So we're on our way home, but we don't quite make it to the top of our graph because that would represent our house. But we make it to, we're on the way and we stop at Sonic. So we stop, so our time is continually increasing while we're sitting there drinking the strawberry cream slush. But our distance is not increasing because we're stopped at Sonic. Okay, after that, he continues home at the same speed as before. Okay, so then our final part would look like that. And we should end up at a relatively the same height as we started, since that represents our house. Qualitative graphs.